This is RTP. This is RTP180.
Thank you all for being here. It's a pleasure to be here. And what a great kind of like age we live in today, right? I mean, it's the new age of machines where you can talk to the machine and actually expect to hear back something from the machine. I mean, you probably spoke to machines earlier when you're like depressed or you're angry. You probably said something to your car when it broke down, but heard nothing back, right? But everything's changed now. So I'm kind of like pretty excited to be here to talk about virtual assistants. That is my kind of like topic for the evening today, and we'll just dive into the guts of how virtual assistants work and kind of like some of the technologies that are powering virtual assistants. And just a disclaimer, I don't have a PhD, and in this age, you don't need a PhD to kind of like do all the stuff that that's happening here, right? So, thank you. So, just kind of like putting out a definition of a virtual assistant here. I mean, everyone's used it. Siri, you have your Google Home, you have your Alexa, you have things on your phone now, on your watch. They're all virtual assistants. They're here to kind of like help us, like real users, kind of like perform tasks, right? So the main technology is powering them. Obviously, there are natural language processing that is a part of artificial intelligence and also machine learning, right? So if you think of artificial intelligence as kind of like Russian dolls, the outermost doll is the artificial intelligence, kind of like the big paradigm. And within that is like machine learning. Like if you pick out the first doll, right? It's a subset of artificial intelligence, mostly to do with statistics. Nothing magical. Everything is kind of like math, right? Everything is math. And the last kind of like if you pick out like machine learning, there lives NLP, which is like natural language processing. So just some stats. I think everyone showed stats, and I probably should show stats on how some of these technologies that are coming up will actually help both businesses and users kind of like make their lives and business easier, right? So it is estimated by Gartner and like I think Forrester saying like around 65% of kind of like the interactions between customers and businesses are going to be driven by kind of like virtual agents and not human agents. I think that goes back to Bonnie's point on like telemarketers being the first guys to be hit. Like you don't need to talk to a person on the other end. You're just going to like talk to a system, right? Big savings in terms of like the money you can save by kind of like onboarding some of these new technologies, and obviously time is money. So there's everything in the equation right there. So how do bots actually work, right? I mean, it's kind of like pretty simple on the outset. You have the user using one or more of the messaging platforms, right? I mean, you could be on your Facebook Messenger, you could be on your Google Home, you could be on Alexa, anywhere. They can type, they can talk to the messaging platform, and from there, the backend system that picks it up, right? So the system that powers it goes through natural language processing. So what happens in natural language processing is like if you're typing things out, it's pretty straightforward. There is text. It's going to be transferred into kind of like a vector or like an array of numbers, and then like a bunch of math's going to be run on it to kind of like determine what you're trying to say. If it is pictures or if it's like when you're talking, it's kind of like a little more interesting, right? How do we actually compute or figure out what you're saying versus what you're typing, because you already typed what you want to say. So when you're saying things, it's again like math. You're going to use high school math, Fourier transforms. If anyone's kind of like read about it, use Fourier transforms to kind of like pick out the frequency and pitch of what you're saying, convert that into a picture called a spectrogram, right? A spectrogram, you guys can Google that up, and then translate that picture into like an array of numbers, and then kind of like figure out what you actually said from that. So it's like a multiple step process of actually trying to figure out what you're saying when you're actually using voice. And once you kind of like figure out what's being said, that is the intent of the user. So that's what you're trying to gather from what they're saying, right? If I said like, hey, Alexa, I need to like deposit a check, right? So depositing the check, that is the intent of the user. That's what you're trying to get at, because once you get at the intent, you can fire off some kind of like code in the back end to say, okay, this person wants to like kind of deposit a check. What is it that I need from him, right? You obviously need the picture of the check next. So that is the logic that kind of like drives back and forth, saying, hey, Tom, like, can you like scan a picture of your check next, right? And once we get the picture of the check, there's no more like natural language processing involved there. We jump to machine learning because we need to pick out the check amount or the name of the person or the bank that needs to get the amount deposited. So that is where like machine learning comes in. So natural language processing is like a subset of machine learning. Machine learning is probably used for bigger problems like object detection, where you kind of like want to figure out who's in a picture or what is in a picture, speech translation and things like that. Natural language processing is just kind of like figuring out what the user has been said, what the user is trying to say, right? And once these kind of like things come into play, it's all straightforward. I mean, everything else is kind of like legacy technologies, right? In the like at the background there, the bot logic going kind of like information sources to pick out what information needs to be delivered to the user or what more needs to be collected from the user, right? But there are some real challenges. I think just kind of like listed here, and it's all kind of like our doing. I think it's kind of like the complex languages that we've developed as humans to interact with everyone else that's leading to all of this stuff. So having kind of like synonymous words, I mean, there could be one word that said and meant one thing. Why have synonyms? I don't know. But that's how we've developed, right? So we can understand synonymous words, but how does a machine interpret it, right? And even more difficult is polysemy. I mean, okay, we thought we had a word, it had a meaning, that's fine. But why does the meaning change in different contexts, right? When I said a bat, which is like a flying bat, versus a bat that's like a cricket bat or a baseball bat, I mean, that totally changes the context. So, I mean, we could probably understand it, but training machines to understand that is kind of like pretty critical, because you want to serve the user for his intent. The other one is also the more trickiest one is the sentence formation. I mean, we kind of like talk haphazard, but because our brains are pretty complex, we understand what the user is trying to say. If the user said Venetian blinds versus a blind Venetian, I mean, they're totally two different things. And what changed is just the order of how I said it, right? And then I listed more things, and I think the more important ones here, metaphors. He's a walking encyclopedia. I mean, is he a human or he's an encyclopedia, and can encyclopedias actually walk? And all of this stuff, right? So these are challenges that some of the algorithms are kind of like trying to address today. And hopefully in a few years, we kind of like all of these will not be so important. But if you are able to cross over all of those challenges, there are still challenges about actually presenting this to a real user to consume, right? You want the user to know about the capability of your virtual assistant. I mean, you cannot assume that the virtual assistant that's trying to like deposit a check for you can answer your question about weather in India, right? So kind of like when you design a virtual assistant, be upfront to the user and set expectations about the capabilities of what it can help the user with. And also it helps to have a personality. I mean, everyone associates Alexa with like, I don't know, maybe a female voice. Like, I mean, there is a personality to Alexa, and probably not to Google Home, right? So it's always nice to have a personality, to have that kind of like a personal touch to the user. Important to use clear and concise language to kind of like interact with the user again. I mean, you have users from various backgrounds, various skill sets, various kind of like brain power. So easier to just use simple language to kind of communicate back and forth so that the bot doesn't get confused, right? It'll be helpful if you can use multimedia to interact with the user. So if the user were asking, how's the weather here? I mean, show them a picture of how the weather looks like, along with kind of like reading out what the weather feels like, right? And also, the last point I think is the most important point, and kind of like distinguishes some of the newer virtual assistants from kind of like older chatbots that were more rule-based, where they said like, if you said this, I would say this. They had no context, but the newer ones like Alexa, Google Home, again, I'm quoting the best of the world. They always kind of like track what the user has already said, have like a long-term memory or a short-term memory, and kind of like use that to the advantage to kind of like answer our questions better, right? So this is how you can create like a good or a great customer experience when you're kind of like rolling out a new virtual assistant to end users. Thank you.